Hello everybody, welcome back to From Rhythm to Algorithm. Last episode we've been exploring the ideas of natural definitions, just that words have inherent relationships to other words outside of any one individual, which shouldn't be surprising, but when you see certain examples and you don't really think about it, it's kind of interesting. We discussed liability, the natural definition, self-contained within the logic. Liability is the ability to lie. Whereas when you think that as an obligation, a responsibility, or a risk, wherein the natural definition is the ability to lie. So we're going to continue that on and apply a lot of these concepts and all of these concepts back to physics today. Because remember, we've modified or extended the implications of the mathematical operators. Sensorality subtracts. To remove something is to censor something, you're subtracting it. So that is logically consistent. And so now we have to modify and show the relationships with physics. And so we're going to use the physics terminology and try to begin to integrate sensorality into there and see where we can get to. Have a pretty good result. A lot of derivation. I'm sure we'll begin physics, mathematics, and linguistics all kind of pretty much all at the same time with every episode, but mainly physics today. Really trying to play around with the natural definitions of fundamental physical words. Stuff like work, energy, vibration, rhythm, momentum, and see what unique relationships we can draw. But to start, the first physics theorem I have is mass vibrates. Again, vibration stabilizes into energy, energy stabilizes into mass. And your phone proves that. Your phone literally has the vibration setting on your phone is a proof that vibration causes, or that mass vibrates, and that vibration can cause motion. And so motion emerges from vibration. But I also wanted to think, can we extend the equivalence principle? What would be the natural definition of the equivalence principle? A principle that is equivalent. And so it's presented as Einstein saying, if an observer was in a gravitational field falling at 9.87 seconds, the Earth's gravitational numeric representation, or if it was accelerating at 9.8 meters per second squared, they would be equivalent. So if you're falling in a gravitational field or if you're accelerating at the same rate, it's indistinguishable to the observer. You couldn't feel a difference. Right? So now we're getting back to Einstein's intuition and sensorality of feeling. Right? That's the whole thing, is the continuous pressure gradient. You're always touching something. If I slam my foot on the ground, that momentum literally gets transferred to you, the viewer watching this. The amount of momentum is so profoundly minuscule you would never affect your motion or you would never feel it, but it's still getting to you. In the same way, if I slam my foot, my chair will vibrate a little bit. It'll vibrate more than my whiteboard over there that's farther away. And so then you can have a inverse square law or something in terms of the dissipation of how a vibration transmits, but it doesn't degrade. Remember, now we're saying gravitational waves, light waves, but mass stabilizes, or vibration stabilizes into mass. So when mass vibrates, it's the whole environment is vibrating. Mass creates space. By stabilizing where mass used to be, that void, that is space, but you really define matter as opposed to space. We'll cover that way back in the very beginning ones, but the equivalence principle in general. Can we have an equivalence between the concept, the physical reality of suspension and the physical reality of flotation? We covered buoyancy in Archimedes extensively, but is that also an equivalent? What it means to be suspended, because now we've described a lot of the ingredients, the different properties, momentum, vibration, rhythm, energy, frequency, and any ones that I missed, but now we have to, kind of describe our environment a little better or build that intuition. And so, can we have, again, reviewing as right, you wouldn't say you're in a liquid right now, but we've really challenged what utility the different phase states have, liquid, solid, gas. It's kind of just like a stability thing. Does it fit? Is the volume well defined? It's really relating to volume. But can we have an equivalence? But we're again saying we're viewing our reality, the world, the physical world around us as like a liquid with just different local densities. Again, not super important, but trying to draw, is there suspension and flotation? If you're suspended in a liquid, or if you're floating in a liquid with a different buoyancy, suspension is, to me, intuitively and physically equivalent to flotation. So I think we can extend the equivalence principle. Again, that was just a leftover one from a long time ago, but what is the relationship of collision and force when two objects collide? We've discussed the mathematics of that is represented by the dynamic limit, because you cannot measure an instant. Some amount of time has to pass for any measurement to transmit data. But what is elasticity? We have to, each independent object, we're using the spherical assumption and, to make the problem easier. But even so, how about the elasticity of a sphere? If something gets X amount of momentum, X amount of energy imparted onto it, how much does it, vibrate? How much does it wave? What can we say about elasticity and vibration and waving? Because elasticity is deformability. How well can it return to its original form, its original shape? Just another physical property to consider. Viscosity, flow resistance. Now we take up anything that doesn't aid motion. Rhythm is proportional, or work is proportional to rhythm, right? If you're at a work or if you're in a group and you want to keep the momentum going, you're getting a lot of things done, very intuitively. Rhythm improves momentum. You're in a rhythm, you're in a groove. But so conversely, rhythm limits resistance. And so anything that isn't rhythmic is resistant. And so rhythm limits resistance, and that's a fundamental, again, rhythm and vibration at this point, they're not in fundamental physics ontology, and it should be clear as day, truly undeniable to anybody, that rhythm and vibration are basic physical principles. Vibration being the absolute basis of the physical world, and then rhythm being the dominant principle or property of how matter moves in time to limit its inefficiency, whether you're dancing or moving a box in an assembly line. If you want to do something more efficiently, you're going to form a rhythm. And so again, we pointed out that vibration does not have a physical definition. If you Google it right now, it will say an instance of vibrating. So you have tautology there. So you have a clear physical phenomenon, undeniable, and then what are the words we use to describe it in physics? Doesn't exist. And so we're extending the logic literally of the ontology of the species. But there's a phrase, because we also introduced this idea of tension. And if you take one object and remove it from stable equilibrium, you've created tension. And so again, another thing, sexual tension, just tension in the air if you're in an argument. Another physical phenomenon that's a tension in a string is completely, right, string being the most basic physical object you can be, represented by ing, the vibration syllable. And, but forgetting what I was saying, there's a right, so you have tension, and there's a phrase called pick up the slack. So if someone tells you to pick up the slack, what are they telling you? Right, become more efficient. But they're alluding to tension, right? If you have slack in a line, it's not taut. It is not tense. Taut, T-A-U-T, if you're just listening. But it is, again, we have all of these phrasing that are evident and allude to these different fundamental physical principles, vibration, rhythm, tension, that are just not integrated into physical ontology. But we've already defined tension path, just independent objects connected through pressure. I'm gravitationally connected to my chair right now. I'm sitting down. The Earth is the big dominant mass in this locality. It's pulling me down. So I exert a force on my chair. My chair exerts a force on me. We're combining that into pressure, taking in consideration the surface area of those two objects, and that point of connection that is represented by our dynamic limit is the tension path. I am object 1, the chair is object 2, me connecting is completely represented by element A, dynamic limit, plus element B. And that is a tension path. Everything is touching, nothing is touching, everything is connected. And so we're just taking a locality of that, because again, everything would be the universe. But if you're saying pick up the slack, you're saying be less inefficient, and you're alluding to tension. Suspension is equivalent to flotation. How do we model environmental conditions as a liquid? Do states of matter suffice? It is safe to say states of matter do not suffice. Again, we can immediately resort back to the fundamental stability of two, so there wouldn't be three states of matter or something. I don't know, but I don't like gas is the most farthest one out there, but just the states of matter in general, I think we can just throw that kind of away. But moving on. So we have, what I want to do is, well, for the tension, again, connecting it more physical intuition, tensing is flexing, right? Flex your muscles right now. You just increase the tension of your muscular system. And so that has, again, logical, physical, linguistical connection, obviously. But we talked about light reflecting and then mass reflexing. Again, trying to work out what light is exactly, or what do we do with the word logically. But what is the relationship of tensing and timing? Consider an animal, a bird, looking to catch a fish. It's going to have to calculate the refraction of the light through the water. The fish is swimming at a rhythm, or with a rhythm. It's in rhythmic motion, so it's got a predictability. The hawk can predict where the fish is going to be, just ignoring the refraction of the water based off of the rhythm of the fish moving, so it knows where to dive to. So it goes dive and grabs the fish, and it tenses its muscles and latches its claws onto it, right? Using tension and rhythm to move. And so, right, rhythm creates an expectation in tension times. Right, when you're going to dunk a basketball or jump up and catch a baseball or something, you're using tension to time. So showing again how those things hold logically and they're physically consistent. But we talked about absorption a lot in the last episode. And I just have a bunch of definitions in my derivation book. This is my lessons plan if I was a teacher at a university, and this is my work where I'm just deriving whatever comes to mind. So let me read through there, and now we're going to work on the physical definitions and draw any insight we can.